Okay, we'll start with this one, this section on differential equation. Okay, so the first course outcome starts from here. Okay, so this one. Okay, so we will start with the first order, first ODE. Wait, sorry. Okay, so what I'm going to cover today is on how we can solve first ODE. Okay, you may refer to this page number. Start with here. So basically, this the first course outcome contains how we can solve first order of a differential equation, including the second order. Okay, so that is the uh, topics covered in the first course outcome. Okay, so we will start looking at uh, what is the method to solve first ODE. Okay, so I'll just call it as first ODE in short form. So ODE refer to uh, order of differential equation, what we call ordinary differential equation. Okay, so several methods. Okay, I will just highlight first, and then we are going to see detail. Okay, so what is the difference? So here we consider for first ODE. Okay, the first ODE, first for the first type, first order. Okay, method to solve is depends on the types of ODE. Okay, the types of ODE. So which method is suitable to solve is depends first on the types of ODE. Okay, this is first ODE. dy dx. You are common with their symbols, right? In other words, we can use labels such as y prime. Okay, so this is first ODE. This is example for second ODE. Okay, so the order of differential equation is depends on the derivative in that equation. What is the highest power? Okay, so for example, in this equation we have this derivative, only one derivative, right? Derivative function. The highest degree at this dy dx is 1. So that's why we call this equation as first ODE. Okay, second one, this we call as second ODE because we have derivative. Okay, but the highest order at the derivative is 2. Okay, that's why this ODE we call second ODE. Okay, or we call it second order of differential equation. Okay, so in some books or some reference book, they refer ODE as ordinary differential equation. So ordinary refer to the first and second order. Okay, it can be third order also. But in different books, they are using ODE as order differential equation. Okay. Okay. Any question so far?
So far, okay, miss.
Okay. Okay. So we'll now we proceed to the next one. Okay. So since that the problem is in the first course outcome is how to solve the ODE. Okay. So we are finding what is the types of the solution first, before we start solving or looking at the method. Okay. So there are two types of solution for the ODE. Okay, this one refer to for any types of ODEs, either it is first or second ODE. Okay, first one we call as general solution. Second one is the particular solution. Okay, so what is it the difference? General solution and then we have particular solution, for example. Okay, general solution is the solution that we derive from the methods. Simply, very simple at the first stage. Particular solution is the solution that we derive after the general solution by substituting the initial value given in the problem. Okay, so it means that the first solution that you will reach is the general solution. Okay, and from the general solution you will reach to the particular solution. So in order to get the particular solution you need to use the initial value given from the problem. Okay, so can you see the difference, general solution or particular solution?
Yes, madam.
Okay. Okay, so how to identify whether in that problem is the problem that asks for the general solution or particular? Okay, look at whether in that questions or in that problem, okay, is there any initial value or not? Okay, the first one, the problem will state what types of the solution that the question asks for. Maybe, for example, like this problem 2, it's clearly state the determine general solution. Okay, so uh, second question here we have what? Problem 3, find the particular solution. So it is clearly state. Okay, so utilize. Maybe in different questions, they state as determine the solution of the ODE given that something lah, with the initial value. X equal to 4, dy dx equal to 2, for example. Okay, so if the question is not very clear, you just say probably determine the solution, or you just say that solve for the ODE with some initial value. Okay, so if the question is not direct like this, stated in problem 2 or 3, it's not direct, is mentions generally. So, but the initial value given. Okay, so mean that is asking for particular solution. Okay, so there are different types of the general solution. Now we'll start with general solution. Okay, either in this form, the one in this form, is this is one part, but the one given here, the one on the right hand side of this equation in this box, okay, is the method to get the answer of the solution. Okay, that is the first method. This is the first one, number one. Okay, and then we have let me okay, let's see, number one. Then we have number two. The form, I just want to highlight first what is the form. You are going to see later on in detail. Okay. Number two, it has different general solutions in this ebook. Okay, in the box here, you have this form. This is one type of the general solution. Okay, then we have number three. The third form, this is the form of general solution. Okay, and then we have different form like this. Okay, but this is a different type that we call homogeneous. Okay, what is the difference on this section? Just now with this one, okay, is the form of the ODE. The previous one and this one, what is the common is both are first ODE. Okay, but the first one is not homogeneous. This one is homogeneous. Here we have homogeneous. Okay. Okay, so this is the fourth one, the fourth form, and here we don't have a basic form of the general solution, but there is a specific or special techniques. Okay, to get here we call it separations, and then okay, this form. Okay, this is the fifth one, but this is linear. Linear first ODE. Linear means that the degree at each variable, okay, the degree at each variable is 1. That's why it's called linear. Okay, so method here is the integrating factor. Okay, so that method sum up for the first ODE. Okay, we'll start with the part 1 first. Huh? Okay, so first part is main. The main method is called separation of variables. Main methods, but separation of variables contains different techniques. Not only one method. There are several techniques belongs to the separation of variables. Okay, so I will review the first one. So everything or what is the techniques that I discuss, okay, today and the next class on Thursday will be involving the separation of variables. Okay. Okay, so first one using separation of variables, we can use separation of variables when we have that the ODE on form that I highlighted here. Okay. Okay, so the separation of variable on the first technique, whenever we have the ODE, transform to this form. Transform or modify. Okay. So and then you do direct integrations, or maybe you have to use special techniques to do the integration. Okay. Direct integration, what I mean is from the formula list, direct integration, look at this second column, direct integration. This one is a formula of integrations. This one. Okay. If we want to integrate sine, so the answer will be negative cos. Integrate cos is sine. Okay, so I will call it as direct integration. Means that you can just refer from the formula list and then you get the answer. Okay, so that is my meaning of direct integration. Okay, so if you need to do special method, okay, special method is special methods or special techniques of integration. Now we are consider considering the integration parts, right? integration methods. So if I call it as special method means that you need to do or apply special techniques to do the integration. Okay, special technique, for example, integration by parts or integration using partial fraction. Okay, or we can have integration using substitution method. So that is special techniques. Okay, special technique means that you're not able to get the answer from the formula list. You need to apply special techniques in order to do the integration. Okay, so are you clear with my explanation?
Yes, madam.
Okay, direct integration and also special methods or special techniques. Okay, so in the first techniques of separation of variable, if the ODE is in this form or if it's not given in the form of this one, but you can transform or modify it and then you can apply this method, and the method means that you will get the general solution by looking at this, do the integration on the right hand side. Okay, so that is the meaning. Okay, so for example, going to zoom this one. Okay, so the one just now we have, see, yeah. Okay, so the first form or that given just now is your dy dx is equal to what? Fx, right? Okay, so let's see whether this one is in this form. Can you answer? Yes or no? Answer yes or no. In problem 2, determine the general solution. We have this ODE. Okay, so my question is the given ODE is in the form? So please answer my question. Yes or no?
No.
No, madam.
No, madam.
Okay, so it is not in this form, but you can modify it, right? You can modify or you can transform. Okay, so how to transform it? Okay, just bring it this one, bring it to the right hand side. Okay, so here is times, right? Times. So bring the other side means divide. Okay, so it means that we have dy dx equal to 2 minus 4x power 3 over x. Okay, so this is this is a one simple fraction, but you can separate like this. Okay, these two are equivalent. Okay, so from this dy dx, this is dy dx. Okay, this is form. So you will get the solution, general solution, when you do integrate. Okay, so this is your fx. Okay, so when we integrate dy dx, you will get y. This is your general solution. Integrate with respect to x variable. Okay, so integrate this one. Okay, let's see. Okay, it's have been written here. Okay, So we are going to integrate this one with respect to x variable. This is 2 constant, right? So take it in front. So mean that the process is equivalent to integrate this. Okay. So integrate ln. Integrate ln. This is integrate 1 over x. Okay, let's see in the formula list. Integration 1 over x. Okay, so the answer is ln. This is absolute or modular symbol. This symbol, this symbol, the line, the these kinds of straight brackets. So the answer of 1 over x, the integration, is ln x. So we have 2 ln x. Okay, this one, direct integration also, when we refer to the formula list, goes to this rules. Number 2. Okay. So we'll be having 4x. This will be plus 1. 2 plus 1 will be 3. So we have 3 over 3. And then plus constant. Okay, so general solution. So this is your y. Y equal to this one. Okay, so in the problem 2, there's no initial value given. So we just solve it by finding the general solution. Okay, do you have questions so far? Is it clear? This is just direct integration. Any question?
So far, no, Miss.
No, madam. So far, okay, madam.
So far, okay. Okay, move to the next one. Okay, problem 3. I'm just taking this problem 3, particular solution. Okay, it's a particular solution. Okay, if you can see that in this, we have initial value. This is example for the initial value. This is our ODE. The order is 1. Okay, so this is first ODE. So in order to solve it, we do same thing. We modify the equation. We can see that the given ODE is not in the dy dx equal to something, right? So you have to modify. Okay, so to modify this, okay, first one we write down 5 dy dx equal 3 minus 2x. So this bring it first to the other side. And then we divide by 5. Okay, so now we have dy over dx. So we have this form. Okay, so same thing. We have direct integration, so you can refer to the formula list for the answer. Okay, so here when we do the integration, so this part will becomes 3 over 5x. And then we have here 1 plus 1, right? So we have minus 2x power 2 over 2 times 5. So this part can be cancelled out for the same constant. Okay, and then we have here plus constant. Okay, when we reach at this one, this is general solution. Okay, but in the question just now, it's asking for the particular solution. Okay, so how to find the particular solution? Okay, use the initial value given in the question just now. Okay, the conditions given, the boundary condition given, y equal to this value and x equal to 1. Okay, particular solution is you need to find out what is the value of c and then write it down again. Okay, so you have to use these two values, plug in into the general solution. So this is y equal to what? This is 7 over 5. Your x is 2. Okay, so this change to 2. Okay, this is 2 squared, then we have 4. Then we get value for C. Okay, so we get that, then we have C as 1. Okay, so that don't just stop here. You need to write down the particular solution. Okay, so particular solution, you just need to write down. It is a general solution, but the value of C should be written. Where is that number? Okay, so here, this is the final answer for the particular solution. Okay, so is that okay for this example?
So madam, particular solution ni just nak cari C lah.
Yes. So selalunya student lupa nak tulis balik the particular solution, equation untuk particular solution. Selalunya student stop sampai nilai C sahaja. Ini yang common mistake yang saya selalu jumpa lah. Dia kira sampai C je, tapi equation untuk particular solution tu dia tak tulis. Okay? So particular solution tu you kena tulis lah what is the equation. Don't forget. Sebab this is common mistake yang selalu saya jumpa. Okay. How about others?
Miss, sorry, boleh tak
Yes.
kalau apa explain balik general solution? Sebab tadi Miss has been the call, so saya terkeluar.
Oh, general solution tu adalah solution yang kita dapat pada peringkat awal. Particular solution ni nak dapatkan dia, you kena dapat general solution, kemudian baru ganti nilai, then you dapat particular solution.
Okay, Miss.
Okay. Okay, so untuk previous example, for the previous example that I provide to you, I think most of you are familiar with dy dx kan? Dy dx notation, but you need to adapt the changes when the ODE given on different form. Kalau tukar form untuk ODE, you kena tahu that is ODE. Okay, so kena guna simbol ODE yang diberi dalam problem. So you need to adapt the changes. Okay, for example, this problem number 4. Okay, solve the equation. Okay, you can see that this is our ODE. Which one is the ODE? Derivative is here, right? So this is derivative. And there is boundary condition given. Okay, so if you can see here, the form of derivative is not dy dx. It is d theta dt. So you have to use that symbol. Don't change to dy dx. So use this symbol in terms of d theta and dt. Okay, so we can check that this is the form that is not into our derivative equal to something, right? Okay, because there is a brackets and then there is some function that we have here, 2t and t. Okay, so you need to open the brackets first. Okay. Open the brackets and then just explain only on the left hand side as your derivative function. Okay, so first we bring it this 2t, bring it to the right hand side. Okay, so here you have t minus d theta over dt equal to 5 over 2t. Okay, then we have transform again. So you can have like this d theta over dt equal to t minus 5 over 2t. Okay, so from this one, now it's the same, right? It's the same, okay. So, we do integration with respect to t variable. Okay, with respect to t variable. Okay, so I'm not showing what is the answer because this one is direct integration also. You can do direct integration here, then it's also, you can get the answer from the formula list. Okay, so final answer you get here plus the constant. So plus the c, the constant, is your general solution. This is the general solution. But you see there is a boundary condition given here. Theta equal to 2 and t equal to 1. So use this boundary value. Use this boundary value. Okay. Substitute here. Your theta and your t. Okay. So your theta is 2. This is your 2. Your t is 1. Okay. Then you will get c value. Okay. So C here you will get 3 over 2 and don't forget to write down the particular solution. So C 3 over 2, then you just write it here plus 3 over 2. Okay. Any question for this example?
No, madam.
Okay, so I think I'm going to stop. Okay. Uh, the tutorial for today is this one. This exercise 178. Okay. Exercise 178. Okay, do it all question 1 until 8. So this is the tutorial for today's lecture.